Hello everyone, this is Abhay Sharma for thinkingpenguin.com, and in this video I'm going to talk about search list element node. But before that I have some change of plans which I want to tell you because I think I'm moving in a wrong direction. What I'm doing right now is explaining each node in detail, which I want to do honestly, but we all know that it will take forever because animation nodes has a lot of nodes. The purpose of creating this playlist is to create basic tutorials. So instead of focusing on individual nodes, I will be focusing on more basic concepts like loops or functions, etc. Loops are keep coming in almost all my tutorials, so I think it should be cleared first. So the next tutorial is going to be on loops. Alright, let's get started. Create the search list element node from the list options. This node is used for searching for an element or elements in a list. Let's create a list and connect it to the search list element node. Let's add some elements to the list. Let's see the current output of the node. Currently we are searching for the 0 in the list and there is no 0, so the first element is set to -1, which means it does not exist. Let's search for something which does exist in the list. It says 2. So if you count the list index 0, 1, 2, the element 3 exists and appears first time in the list on the list index 2. All indices creates a list of indices of the found element in the list. Occurrences tell you how many times a searched element exists in the list. So if I change one of the element to 3, you can see occurrences says 2 times. First index is still at 2 because it only cares about the first index, and all indices has created a list of 2 indexes where 3 exists. Alright, so that's the basic functionality of search list element node. Let's see an example. This time I'm going to use a particle system, and with the search list element node we will try to find those particles who died in a certain lifespan. So first let's create a particle system. Okay, particles are emitting. Let's make some changes. I'm gonna set the lifespan to 20, random to 1, and number of particles to 200, and end time, emission end time to 20. Alright, let's import the particle system into animation nodes. Create a particles from object node, select our torus, create a particle list info node. This node will give us all kinds of information about particles. By default it only shows locations, but I need die times, which you can enable in the N panel. Let's see the output. So this is the list of particles die time, and I can, if I want to extract one or more particles based on the certain die time or between range of die times. Let's create our search list element node, and let's say I want to see if there is any particle die time is 10. So let's see the output of these nodes. Occurrences set to 0, which means no particle has a die time of 10. Alright, let's give a value from the list. It's still 0. 9 exists in the list. Maybe I have to add some precision to it. Let's type 9.05311. Now it detects, but if we have to search things in this way, it would be pretty painful. Let's try one more time. 9.05. Nope, it doesn't work. Alright, let's make this node a little smart. Let's loop through die times. Now we will compare each die time to some number so that we can filter out the desirable particles. Let's say any particle whose die time is less than 10. Let's add a switch node. If it's true, then it will be 10. If it is false, then it will be 0. Actually, any value will work as long as they are different. We are just flagging it. Let's create a generator output. Select float. Now we have a custom float list, which is a filtered list from the previous list. Let's move these nodes down. By the way, you can use the EPI menu key and select dependent nodes to do the same thing faster. Alright, let's see the output. Let's compare the list side by side. You can see whatever value is less than 10 in left list is 10 in right list, and whatever value is above 10 in left list is 0 in right list. Now let's search for 10. And there are 22 particles whose lifespan is less than 10 frames. Now let's place cubes on these particles to visualize. Create a cube. Create an instancer node. How many copies do I need? Well, 22 in this case, but we are not going to change this value every time when search result changes, so we will just connect it with occurrences. Now let's create a loop. And we are going to iterate through objects and integers because indices data type is integer. Why indices? Because we are going to place our cube on those specific index numbers. Alright, let's create our invoke node. Connect indices to index list and object to object list. I'll rename these fields. Now we need the original particles location list as a parameter because this is where the particle's position is stored. Now let's create a transform output node. Connect object to object, vector list to locations, and searched index list to index. Now you can see that our cube jumps on those particles whose lifespan is less than 10 frames. Let's turn off the relationship lines. It should be off by default. So right now we are getting particles whose lifespan is less than 10 frames. But let's say we want particles from a certain range of die times. Okay. Let's duplicate the compare node. Change the first one type to A is greater than B and second ones to A is less than B. Connect it to the loop. Now we have to combine these nodes. So create a logic node. Set the mode to A and B, which means both condition has to be true. And here you go. Let's try 15 to 20. Alright guys, thank you so much for watching. Next tutorial is going to be on loops, so buckle up. Until then, see you later.